Hello and welcome to the first day of Unit 2. We're going to be talking about transformations. Okay, so you're due now. You should have this on your paper. I know it's a little small, hard to do, but this is what your two shapes should look like. Okay, when I think of transformers, or transformations, I think of transformers. If you want to watch a quick clip, you can go to pause the video, go back to Canvas, and there's a link. And you can click on the YouTube link to watch a quick Transformers clip, and then think to yourself, what is a transformer? What are the different transformers that you've observed before, and what do transformers change into? All right, that's just to activate your learning. So some key information, some key vocabulary words that you need to know is that transformation maps or moves a figure around a plane. When the figure is in its original position, it's called a pre-image, and then after you move it, it's called the image. So here you'll notice that the pre-image was here, and then we moved it across, reflected it to the image. Okay, and there are several different types of reflections, rotations, and so the 4 types. You might want to pause the video to see if you can list them on your own. But you should have a translation, reflection, rotation, and then lastly is a dilation. And so if you want to know what these look like, this right here, you can see that there would be a line of reflection right here. So this one is reflection, so I'm just going to put number 2. Over here, you see that you're sliding this cat along a vector. This is called a vector. So we're going to call that translation, which is number 1. Here we've got this cat that's turning, and this is going counterclockwise. So we call this a rotation, which is number 3. And notice this cat went from a very small cat to a very large cat, or vice versa. And so we call this number 4, which is a dilation. This is the only one that creates similar figures. All the other ones, the figures you can see, stay exactly congruent. Okay, so today we're just going to focus on reflections. And so when you think of a reflection, you can think of a line of symmetry. So your body has a line of symmetry down the middle. If we were to look at this picture of the swan, we could see clearly that the line of symmetry is right here. And our eyes really like lines of symmetry. We like to see things in balance. And this young lady right here, you can see that if you drew a line kind of right here through her body, this image on the right side could fold over and be on the left side. Now, when you're looking at the Spalding basketball, there is no place where you could draw a line and get the same thing on both sides because of the writing that's here. So this one does not have a line of symmetry. And here, this one's kind of tricky because you could, if these oars were kind of in the water, you could say your line of symmetry was here. But I would say that it's more likely cutting the water again, cutting across the water, getting your line of symmetry there. You might, it's pretty close to having a line of symmetry in both directions. All right, so let's, now that we know what a line of symmetry is, or a line of reflection, let's go ahead and practice reflecting some points. So I'd like you to pause the video at this point and do this discovery on your own, and then come back in a minute and see if you can come up with a rule to reflect over the x-axis, y-axis, and the y equals x line. So try these 3 on your own, and then come back and see if you came up with the same rule I did. Here's what you should have noticed when you did your reflections is that your original image here in red kind of looks like a W, and you're reflecting across the x-axis. So I highlight the x-axis, and it's flipping down. And you'll see I've put these dotted lines to show you that your line of reflection, your points are going to hit your line of reflection and make a 90-degree angle. So they should all be perpendicular. And you'll notice that M is the same distance above the line of reflection as it is below the line of reflection. Okay? And what you should have noticed with your coordinates is all your x coordinates stayed exactly the same as they were in the original pre-image. But what happened was that the y coordinates just changed sign. So if they were originally positive, now they've become negative. And the same is true when you reflect across the y-axis. So when you reflect across the y-axis, notice I've highlighted the y-axis for you. Again, each point is equal distance. So from V to V prime, it is the equal distance from the line of reflection, and they form a 90-degree angle. Okay? What's different in this situation is that your x coordinates are now going to go negative, or change sign, I should say, and then your y coordinates stay the same. So if these x's were negative, they would go positive, but since they were all positive, they all went negative. Okay? Now, a little bit more tricky is when you reflect over the y equals x line. And so that looks like this. This is your y equals x line. It's a diagonal, cutting the coordinate grid in half diagonally. And what you'll notice is your points flip-flop. But if you look here, this point still is equal distance from the line of reflection, and it still makes a 90-degree angle. You just got to count diagonally instead of counting across. Okay, and so what you should have noticed is that your coordinates flip-flop again. So this time, if it was originally in the y position, it's going to flip to the x position, and if it was in the x position, it's going to flip to the y position. So you can see that the two numbers just switch spots. Okay, so these are important rules for you to be able to move forward, and you have to know them. They're also, if you look on the windows, you'll see transformation rules, and you'll see the reflection rules up there as well. Okay, so let's go ahead and practice some of these. Again, what I would do is pause the video, try them on your own, and then come back and see if you got them correct. Another way that we write rules, just so you know, is that you can write this right here, which is, oops, shoot. That's close to where you were. Oops. You can write that this is a reflection across the x-axis. You could just write it as an R for reflection in the x-axis. And you can see the rule here. And then this is what your image should look like. And again, notice that each point is going to cross the line of reflection at a 90-degree angle. For the next image, you should see that your shapes, the original shape is in black, and then the new one is in, the pre-image is in black, and then the image is in red. And you'll see that again, each of your points makes an exact 90-degree cross from the line of reflection. And then lastly, across the y-axis, you're flipping across the y-axis, and so you should notice that the x coordinate changes, but the y stays the same. Okay, we're going to do a couple more, and then you're going to get a chance to do your homework. So a couple more situations is that, what if you don't reflect across the x or the y-axis? What if you reflect across the x equals 3 line? Okay, and so what you're going to do is you're going to look on your x-axis, because it's x, and you're going to find where x is 3. So that's 1, 2. So x is 3 right here. So you're going to draw a vertical line, because that line right there is where x is always 3. Okay, so when x is equal to something, it's going to be a vertical line. And then you do the same thing. You're going to reflect your points. So s is currently here. There is no rule for this. You just have to know that it's equal distance from the line of reflection. So r is 2 away, so I'm going to go directly to r prime, and q is over on the left side, so it's going to move to the right side, 2 away as well. So q prime would be here. So this would be a reflection across x equals 3. And then the same situation goes for y equals 2. You're going to look, so you're going to look on the y-axis, where y equals 2 is right here. So this time, if I drew a vertical line, I would just be tracing the y-axis. So this time I'm going to draw a horizontal line, which is counterintuitive, I get that, but it is what it is. That's where the line y equals 2, and now you're going to reflect across it. So each of your points are going to be, like this one here is going to be 2 away in the opposite direction. And this one's below it, so it's going to go above it. And here k is 3 below the line, so you're going to go 3 above the line here for k. And again, you want your points to be at a 90 degrees from the line of the reflection and equal distance apart. It's kind of like this is your line of symmetry in this image. Okay, so go ahead and finish your homework. You have to do the rest of the packet. Finish it all, show it to me. I'll make sure that you know what you're doing so you can move forward. There are also iExcels that you need to complete this week. They're all posted on Canvas. All right? Thank you.